talk about
synthetic division. In this corner, we have a complete polynomial.
And in this corner, we have incomplete polynomial.
We're going to explain to you how to do the complete polynomial.
The procedure is:
First you put the 2, but with an opposite sign. And then you put the 3 under it. So you have minus 2 over 3, like a fraction. And then you put 6, but without variable and exponent. And then 16 and 8. We don't put the signs because they are positive. And then we make a line. For the first step, you just bring down the number 6. And then you multiply 6 times minus 2, and then you divide it by 3. So it will be minus 12 divided by 3 minus 4. And then you make your subtraction. 16 minus 4 is 12. And then you make it again. 12 times minus 2 is minus 24. Divided by 3, that's minus 8. But these are the same numbers, so you just cross them out. And you have a 0. For the final result, you have to divide these two numbers with number 3. So it will be 6 divided by 3, 2. But you have to put the exponent, 1 degree less than is the original. So that will be 2x plus 12 divided by 3, that will be 4. And this is your final result.
The difference between this one and this one is that in here you have the polynomial complete. You have x squared plus x, and in here you don't have variable, so you imagine that you have the exponent 0. And in this one you have the polynomial incomplete. You have a cubed, and you are missing a squared, and then you have minus 5a, and you are missing the exponent 0.
I'm going to explain the procedure for this example. The first thing we have to do is that we have to put this number in here, but with the opposite sign, so we're having a positive 1. Then this number without the variable as a divisor in here, so we have 1/2. Then we have to put down in here this number, so we're having 4 and a minus 5. As this is an incomplete polynomial, we have to complete it just adding zeros. So we're missing a 2 and a 0. So we add here a 0 for the 2 and also a 0 for the 0. Then in here we have to put the line. We put down to make it like this. 4 by 1, it's 4. But over 2, it's 2. So we need to make an addition or a subtraction as we need it. So 2 plus 0, we have 2. In here, 2 by 1, we have 2. Over 2, we have 1. Then, here we need a subtraction. So we need to do this. 5 minus 5 minus 1. So we're having a negative 4. Then this by this. 4 minus 4 by 1, it's minus 4. But over 2, we have a 2, that is 2. Here we need to make a subtraction or an addition, so it's minus 2 plus 0, we still have minus 2. But this is not our final result. We have to divide everything by 2, but it will not always be a 2. We always have to divide it by the divisor we have in here. In this case, it's 2. We have to divide everything except for the remainder. So here we go. 4 over 2, we have a positive 2. Then, a 2 over a positive 2, we have a 1. Then, minus 4 over 2, we have a minus 2. And here, we don't have to divide it by this number. So we're going to put it exactly the same. And in here, as we need to put the variables with their degree, in here, if we have an a cubed, we have to put not exactly the same, but the same variable, but with a lower degree. So we're having 2a squared. If here we have a 1, the 1 is not written, so we have to put plus. Here we have to put an a squared, but with a lower degree, it will be just a, as a degree of 1. Here we have the degree of 0, and in here, that is our reminder, we have to put it like a fraction of all our polynomial. So we have to put minus 2 over 2a minus 1. So this is our complete result. Thank you.